Earth is never standing still. There is always like waves traveling, there's always some ambient noise going on. Echoes and gloomy and like it sounds a bit dark.
If we want to see what goes on below the surface of the Earth, then one possibility is to use techniques that listen at signals that come from deeper down and can give insight into the processes that happen at depth.
A lot of changes going on in Greenland. The warming rates are 4 times higher than the global average.
Like in the middle of the field where it's a little bit wider than.
The project started with the idea, okay, we want to apply our sensors to different settings in Greenland. It's good for this method, if there is a change, just to see, can we monitor it with our method? Can we actually see these changes? And then based on the processes, on the better understanding, you can find measures against those natural hazards, or at least to do an early warning for settlements close to such slopes. You can look at processes you're not able to look at with other methods. What is happening at the base of a glacier, for example, which is very crucial for a lot of things like how much ice is discharged into the oceans. Hidden from the surface, hidden processes can be monitored with this seismic method. We have sensors coupled to the ground, and we monitor this little ground motion with our sensors. The main thing you will spot if you approach one of our stations will be like a tripod with a solar panel and a big battery box hanging from the tripod.
Hello.
There, the data logger is attached to our sensors. They are just dug in close to the station. Or we had these mini array setups where we had, like in a star-like geometry, the sensors installed 30 meters away of the station. That's all you can hear also. That this is the magnet moving in the coil. Electric voltage will be sent over electric wires to the data logger, and there it will be recorded, and that's more or less our signal.
What we see in the signal is essentially sound. It's just traveling in the ground instead of traveling through the air. And if you process that signal, we can pick up distinct events, like if there is a stone falling, or a person stepping, or a river flowing.
Rock falls. That's like the big advantage of the seismic method, is that we have like a very continuous monitoring of the processes. We are sampling with 1 to 1,000 samples per second.
If you're on a glacier, we can hear the noise of crevasses, we can hear the noise of even water that percolates through the ice and reaches the bed. We can understand if the ground is freezing, if it is thawing, how deep is the thawed part of the ground, and so on. You can actually work out a lot of information that is contained both in the noise, but also contained into the physical environment through which the noise is propagating. So you can learn how the mechanical properties of the rock change just by seeing how much the background noise travels through it. And this is why you need to to use these kind of instruments where you listen at noise in different positions so that you listen more or less to the same thing, but not quite. And so you can work out these subtle differences that may tell you how the ground is changing.
The seismic thing is just one perspective of the whole story. You need different methods, approaches, you need the field data, you need the modeling, just to understand those things going on.
In combination with the other methods, so again, it's not like seismics can alone answer questions, it can provide an element of the answer.
The big question with the whole landslide story in Greenland is how much does the permafrost degradation play a role in those events? And it's very likely that it plays a major role. So it's clear, okay, we want to measure the subsurface temperatures.
So you are on the spot now.
Where I drilled the...
Yeah, Wolfgang will fix the rope then.
When looking at the landscape in Greenland, there are large areas that are underlain by permafrost, which essentially means that the temperature of the ground is below zero. So in these conditions, you would expect that the space in between individual rocks, it would be filled up with ice. And ice is a material that changes its mechanical properties quite dramatically as it warms up toward 0 degrees. And if you have a slope that is warming, this slope will also start deforming. Actually, by scraping the surface, we could see that right behind that, there would be melting ice. There would be an ice core. If you imagine it to be like cement, keeping the materials stuck together, if it goes away because it melts, then the material will fall upon itself, essentially. And so you would have something that looks like a boulder that disgregates into a cone of debris. It means that we are actually very interested in what the temperature is below the surface. And the best way of doing this with certainty is actually to go there, drill a hole and measure temperature in the hole. Greenland, the main problem there is rock falls. Typically, you want to find a location that you can reach safely, making sure that whatever rope or tools that you have above you do not set some rock loose. So after you drill a hole, it is essential to taste how and what exactly you have been drilling into, and this is the device that geologists are already using. That is the good stuff.
So what is
That's what we are after. Yeah, it has an aftertaste, I think. And now the hole is clean. What we do is we drill the hole and then we insert a cable that has temperature sensors at different points so that we can see how the temperature changes from the surface down to 1 or 2 meters.
If you imagine water coming down when it rains, is there a place a bit out of the water better than the other?
The landscape and the processes acting on it are a little bit like an untouched piece of marble and the sculptor working on it. The marble is put there by nature, and we need to know exactly what the geology of the mountain is before we can understand what the effect will be. And so techniques like environmental seismics, they are all providing us small peepholes where we can spy on the sculptor and see what he is doing with the material. And that means that what is a key knowledge that we need for this is also a very close understanding of, a very deep understanding of the actual geology of the material. So these techniques and technologies are helpful to tell us what the sculptor is doing, but we also need to know what the material that the sculptor is working on is like.
very likely that those kind of natural hazards will increase with the climate change.
And seismic techniques and environmental seismics is a very promising technique that can be used to monitor these processes. And this is very important because, again, in a context of a warming climate where permafrost is going to degrade, as a matter of fact, there is no way around it. Once you know the processes that act on a slope, you can pinpoint evidences that you believe will give an early indication that something is about to happen.
The seismic method works for those conditions and delivers good data. So let's set some more of these local networks up in Greenland.